All right, let's dive right into our first topic of discussion, understanding the Earth's axial tilt and its impact on the distribution of sunlight across the planet. Now, you might have heard that the Earth is tilted on its axis, but have you ever wondered why that's so important? Well, it plays a crucial role in creating the seasons we experience throughout the year. And the Earth's axis is an imaginary line that runs through the north and south poles around which the planet rotates. The Earth is tilted at an angle of approximately 23.5 degrees relative to its orbit around the Sun. This axial tilt is responsible for the varying amounts of sunlight that different parts of the Earth receive during its annual journey around the Sun. When the northern hemisphere is tilted towards the Sun, it receives more direct sunlight, which results in warmer temperatures and longer days. This is what we experience as summer in the northern hemisphere. At the same time, the southern hemisphere is tilted away from the Sun, receiving less direct sunlight, which leads to cooler temperatures and shorter days winter in the southern hemisphere. On the other hand, when the southern hemisphere is tilted towards the Sun, it experiences summer, while the northern hemisphere experiences winter. During these times, the opposite hemispheres receive more or less sunlight, respectively. Now, you might be wondering, what about the regions near the equator? Well, the Earth's tilt has a lesser effect on these areas, as they receive relatively consistent amounts of sunlight throughout the year. This leads to a more constant climate, without the significant temperature fluctuations experienced by regions further away from the equator. So in a nutshell, the Earth's axial tilt plays a critical role in determining the distribution of sunlight across the planet, which in turn influences the temperatures and climates experienced in different parts of the world. It's this tilt that gives us the varying seasons we know and love. Moving on to our second topic, let's talk about the Earth's elliptical orbit around the Sun and how it influences the intensity of sunlight received. You might be surprised to learn that the Earth's orbit around the Sun isn't a perfect circle. It's actually shaped more like an ellipse, or an elongated circle. This means that the distance between the Earth and the Sun varies throughout the year. Now you might be thinking, does this affect the intensity of sunlight we receive? That's a great question. Well, the answer is yes.
But not as much as you might expect.
The variation in distance between the Earth and the Sun during its orbit does lead to some differences in the intensity of sunlight we receive. However, this effect is relatively small compared to the impact of the Earth's axial tilt, which we discussed earlier. When the Earth is closest to the Sun, which occurs around January 3rd, we're in a position known as perihelion. At this point, the Earth is about 147 million kilometers, 91 million miles, away from the Sun. Conversely, when the Earth is farthest from the Sun, around July 4th, we are in a position called aphelion, and the Earth is approximately 152 million kilometers away from the Sun. These differences in distance do result in a slight variation in the intensity of sunlight received by the Earth. However, because the axial tilt has a more significant influence on sunlight distribution and temperatures, the Earth's elliptical orbit doesn't cause the seasons by itself. Instead, it's the combination of the Earth's tilt and its orbit that creates the distinct seasonal patterns we experience throughout the year. So, to sum up, the Earth's elliptical orbit around the Sun does play a role in influencing the intensity of sunlight received. But it's the axial tilt that has the most significant impact on the creation of our four distinct seasons. Alright, now that we've discussed the Earth's axial tilt and its elliptical orbit, let's explore the concept of solstices and equinoxes as key points in the Earth's annual journey around the Sun. These events mark the beginning of the astronomical seasons and are important milestones in understanding the Earth's relationship with the Sun throughout the year. Solstices are the points in the Earth's orbit when its axial tilt is at its most extreme towards or away from the Sun. There are two solstices each year, the summer solstice and the winter solstice. The summer solstice, which usually occurs around June 21st in the northern hemisphere, is the day with the longest period of daylight. On this day, the North Pole is tilted towards the sun at its maximum angle, resulting in the highest path of the sun across the sky. Conversely, the winter solstice, occurring around December 21st in the northern hemisphere, is the day with the shortest period of daylight. On this day, the North Pole is tilted away from the sun at its maximum angle, causing the sun to follow its lowest path across the sky. Equinoxes, on the other hand, are the points in the Earth's orbit when its axial tilt is neither towards nor away from the sun, resulting in nearly equal amounts of daylight and darkness across the globe. There are also two equinoxes each year, the spring equinox and the autumn equinox. The spring equinox, which typically falls around March 20th in the northern hemisphere, marks the beginning of spring and is the point when the Earth's tilt begins to move the North Pole towards the sun. The autumn equinox, occurring around September 22nd in the northern hemisphere, signals the start of autumn and is the point when the Earth's tilt starts to move the North Pole away from the sun. In summary, solstices and equinoxes are critical points in the Earth's annual journey around the sun, marking the beginning of the astronomical seasons. These events are caused by the interaction between the Earth's axial tilt and its orbit, resulting in the unique patterns of daylight and temperature fluctuations we experience throughout the year. Now that we've discussed the Earth's tilt, its orbit, and the concept of solstices and equinoxes, let's examine how these factors come together to cause variations in temperature and climate during different seasons. As we've learned, the Earth's axial tilt and its elliptical orbit around the sun are responsible for the changing distribution and intensity of sunlight throughout the year. When the sun's rays shine directly on a specific area of the Earth, the energy from the sunlight is concentrated and results in higher temperatures. On the other hand, when the sun's rays hit the Earth at a more oblique angle, the sunlight is spread over a larger area, causing lower temperatures. This is the primary reason for the temperature differences we experience during various seasons. During summer, the Earth's tilt causes the sun's rays to strike that hemisphere more directly, leading to warmer temperatures and longer days. Conversely, during winter, the tilt causes the sun's rays to hit that hemisphere at a more oblique angle, resulting in cooler temperatures and shorter days. In regions closer to the poles, these temperature variations can be quite extreme, leading to frigid winters and relatively mild summers. In contrast, areas near the equator experience less dramatic temperature fluctuations due to the more consistent angle at which sunlight reaches them throughout the year. It's important to note that the Earth's elliptical orbit also plays a minor role in seasonal temperature variations. As we mentioned earlier, the Earth is closer to the sun during perihelion and farther away during aphelion. This slight variation in distance can result in small differences in the intensity of sunlight received, further contributing to seasonal temperature changes. To sum it up, the Earth's tilt and orbit work together to cause variations in temperature and climate during different seasons. The changing angle and intensity of sunlight throughout the year as a result of these factors are responsible for the unique weather patterns and temperature fluctuations we experience across the globe. As we wrap up our discussion on the Earth's tilt, orbit, and the creation of seasons, let's turn our attention to the cultural and ecological significance of the 4 distinct seasons and their effects on human societies and ecosystems. The changing seasons have a profound impact on the world around us, shaping our cultures, traditions, and even the natural environment. From a cultural perspective, the seasons have inspired countless works of art, literature, and music throughout history. Different societies had developed unique traditions and celebrations around the changing seasons, such as the Japanese cherry blossom festivals in spring, the American Thanksgiving in autumn, and the vibrant Holi festival in India, which welcomes the arrival of spring. The agricultural calendar is also closely tied to the seasons, with planting, growing, and harvesting occurring at specific times throughout the year. This has shaped not only the availability of food, but also the way we eat, with seasonal diets focusing on fresh, locally available produce. In many cultures, seasonal foods are celebrated with traditional recipes and dishes that have been passed down through generations. Ecologically, the changing seasons have a significant impact on ecosystems and the plants and animals that inhabit them. Many species have evolved to adapt to the seasonal changes in their environments, such as animals that hibernate during the winter or migrate to warmer climates. Plant life also responds to the changing seasons, with trees shedding their leaves in autumn and flowering plants blooming in spring. These seasonal changes in ecosystems also have a ripple effect on the food chain, influencing the availability of resources for various species. For example, the abundance of insects in spring and summer provides a vital food source for birds and other animals, while the scarcity of food in winter can lead to increased competition for resources. In conclusion, the four distinct seasons, resulting from the Earth's tilt and orbit, have profound cultural and ecological significance. They shape our traditions, our connection to the natural world, and the delicate balance of ecosystems. Understanding the reasons behind the changing seasons helps us appreciate the intricate relationships between our planet, its orbit, and the life that thrives upon it.